A. What is nanoscience? Nanoscience is the study of phenomena and manipulation of materials at atomic, molecular, and macromolecular scales, where properties differ significantly from those at a larger scale.
Nanoscience is the manipulation of the material of an atomic. See here, you can change. Can you see here the atom position is changed? You can change the position of the atom, and you can change the property of that material. Or you can big molecule you can change, molecular and macromolecular scale. In big molecule you can change the shape and you can change the properties, or you can change the property of this bulk material which is very larger in size. Example, copper, which is a very larger scale. It has a property of malleability and ductility. Okay, and this property can be changed if you make it very small size, that is in the nanoscale size. If you bring this copper in a nanoscale size, that is approx 50 nanometer, that is it is in the range of nanometer range. So you can make this copper very super hard. This was not super hard in the bulk form. Now it has become very super hard material, and thus the property of malleability and ductility is lost.
Define nanotechnology. Nanotechnology is the design, characterization, production, and application of structures, device and system by controlling shape and size at nanometer scale.
Nanotechnology is the design. So what is the meaning of design? See here, in old days we are using typewriter to type anything. Now we have changed laptop. Nowadays we are using, in that we have used a nanotechnology. We have using a small chips, and we can store large amount of information in in a very small compact space. So by using nanotechnology we are designing different devices. Then there is characterization. What is the meaning of this? We are studying the behavior, how the material behave when it is made in a nanoparticle size, and how is the reactivity, how is the properties, color, everything we are studying. Then after studying that, we are producing the that device, and we are applying in certain making certain device, and we are producing it. It is used in various applications, such as in agriculture we are using, in medicinal field, or we are using drugs small in a nano size particle size. Then after devising, we are controlling that shape. To control that, we required a different devices, just like microscope, to see whether that particle is, what is the size, everything, laser diffraction method. There are different instrument we can use to detect the particle size, and by controlling, by using by knowing that particle size, we will see what is that application, what is the property, and how it behaves in a nano particle size.
I'll make a fist and squeeze the tag to the top of my skin. When I approach the device, it opens the Facebook page I set it to.
Colin Cravino has a microchip implanted in both of his hands by retailers to track packages and prevent theft. Farmers use the chips to keep tabs on their livestock. Pet owners use them to identify their cats and dogs. And lately, members of the so-called body hacker movement
doing research on the Samsung deadbolt that I bought. And then the first thing that I noticed was that I could get an RFID tag.
Andreas Sjostrom used his chip as a boarding pass on a recent flight from Stockholm to Paris, and to get into an airport VIP lounge. Skeptics say the implants raise privacy issues and worry that strangers could tap into the information on a chip without the owner's knowledge. Others say potential uses for the technology such as keeping track of a patient with dementia, could pose ethical concerns.
Why nano? The nanometer scale, nano in Greek means dwarf, but in actual case nano is even smaller than dwarf. Nanometer scale? The nanometer scale is defined as 1 to 100 nanometers. 1 nanometer is 1 billionth of a meter. That is 1 nanometer equals 10-9 The materials we see around us are bulk materials that possess macroscopic physical properties. These properties change as a function of size and are very different from their bulk materials.
Bulk material. So whatever you can see is a bulk material. So I take the example of copper. This is a copper. Copper has two properties. One is when you hammer it, a sheet, it can be converted into sheet, or if you pull it, it will be drawn into a thin wire. So it has a two property, malleability and ductility. Suppose if we bring this bulk material into a very small size, that is the as small as 50 nanometer, that is in the nanometer range. When you bring it in a nanometer range, that it became very super hard, and the properties such as malleability and ductility property will be not there. It became very, normally the metal do not have such a super hard material. All the property get lost if you bring it in the nanometer range. It became very hard.
But material synthesized at nanoscale, 1 nanometer to 100 nanometers, possesses unique optical, structural, thermal, catalytic, magnetic and electrical properties. What is a nanomaterial? The nanomaterial is a material having structural components with at least one dimension in the nanometer scale, that is 1 to 100 nanometers.
So what is nanomaterial? To explain this is the picture. You can see here there are different size, there are different structural. What is the definition? Nanomaterial is a material having a structural component. So these are the structural component. So these are different structures here, and they have a or of different size. Below there it is written 0.1 nanometer, 1 nanometer, 10 nanometer, like that, and different nanometer are written here. In this, glucose antibodies, viruses are in the nanometer range. You know that in nanometer range is what? 1 to 100 nanometer. So glucose, antibodies and virus all are coming under the nanometer range. So these are all nanoparticles. Below 1 is not a nanoparticle, above 100 is not a nanoparticle. So to have a nanomaterial, the nanomaterial should have the size which are in the range of 1 to 100 nanometer. And one more thing, what a component with at least one dimension. What is the meaning of one dimension? Is what? There are three dimensions: x-axis, y-axis and z-axis. Suppose in any of the one axis, if that size matches with the nanometer, then it is called as nanoparticles. For example, I will explain you. Suppose x-axis, y-axis, any axis or diameter, anything, we should have one size. Any one axis should be in the nanometer range. For example, suppose if I assume this is a nanoparticle, so it is a length is x-axis, width is y-axis and height is z-axis. Also same thing. In first length, suppose 50, width is 0.1 and height is 120. Out of these three, you can see here this length is in the nanometer range, while the width and height is not in the nanometer range, but it is called as nanoparticle. Why? Because in the definition it is written to consider that nanomaterial, it should have any one dimension should be in a nanometer range. So either one dimension is what? This one dimension, this length, x-axis dimension, it has a nanometer range. Therefore you can consider this as a nanoparticle. Same thing here. 1 second. If suppose width is 50, rest is different, it is below nanometer range and height is above nanometer, but width is in the nano range, then this is also a nanoparticle. Then in third case, suppose Height is in the height, that is z-axis dimension, is a nanoparticle range, but length and breadth are not in the nanometer range. Then also this nanomaterial, this is a nanomaterial.
Nanomaterials are larger than single atoms but smaller than bacteria and cells.
Okay. In this picture you can see the gold atom here. This is the gold which is yellow in color. Gold size is smaller than the nanoparticle size. It is lesser than the nanoparticle range size. So it is less than, so it is not a nanoparticle, not a nanomaterial. The atom is not a nanomaterial, and bacteria and the cancer cell is greater than the nanoparticle size range. So this is also not in bacteria and cancer cell is also not a nanoparticle. So what is nanomaterial? Nanomaterial are larger than the single atom, means more than the gold atom size, gold or atom. Even the molecule of water is very smaller. It is not a nanomaterial. Nanomaterial are larger than the single atom, but less than what? Less than bacteria and the cancer cell.
Nanomaterials may be nanoparticles, nanowires and nanotubes according to dimensions.
Material is changes into very small particle in the nanomaterial range. Therefore, nanoparticle is a nanomaterial, nanowires and nanotubes.
Zero-dimensional nanostructure. A zero-dimensional structure is one in which all three dimensions are in the nanoscale.
Zero dimension example. To have a zero dimension, the length, breadth and even height, means what? X-axis, Y-axis and Z-axis all should be in the nanometer range. Suppose if all the three axes are in the nano size range, then it is called as a zero dimension nanoparticle. Next is
2. One-dimensional nanostructures. A one-dimensional nanostructure is one in which two dimensions are in the nanoscale.
So this is the example. Here this is a nanomaterial, not we'll see in one dimension. Here suppose the width is 50 nanometer and length is 0.1, which is less than nanometer range size, and height is 100 nanometer, which is in the nanometer range. So in this there is two dimension are in the nanometer range. Third.
3. Two-dimensional nanostructures. A two-dimensional nanostructure is one in which one dimension is in the nanoscale.
So this is a nanomaterial, not we will see. In this, so here height is 50 nanometer, width is 0.1 nanometer and length is 120 nanometer. So you see in this only 50 nanometer is in the nanometer range. So this is a nanomaterial. Example.
Zero-dimensional nanostructures. Nanoparticles, quantum dots, nanoshells, non-earrings, microcapsules. One-dimensional nanostructures. Nanotubes, fibers, nanowires.
So there is one more metal nanorods also is a one-dimension structure.
Two-dimensional nanostructures. Thin films, layers, and coatings.
Exciting scientific breakthroughs such as nanotechnology are promising to revolutionize cancer therapy. Many ways in which nanotechnology can greatly improve cancer diagnosis and cancer treatment. Diagnosing and treating cancer can be a challenge because tumors can hide anywhere in the body, and anti-cancer treatments like chemotherapy and radiation affect normal tissues, not just cancer cells, causing side effects. Nanotechnology is a revolutionary new approach to cancer that's showing great promise. What is nanotechnology and how does it work? Nanoparticles are incredibly tiny, so small that 100,000 of them would fit on a single human hair. Nanoparticles can be administered to patients intravenously. They easily float through the bloodstream, seeking out cancer cells wherever they may be hiding. Some nanotechnology is designed to seek out cancer cells and attach to them. using specialized receptors which bind to the tumor selectively. Once bound to the tumor, the nanoparticles send out signals that tell doctors where it's located. This can help accurately visualize tumors that would not show up on conventional medical scans. Other nanotechnology is designed not only to find the cancer cells, but to kill them selectively using specific receptors that attach only to the tumor without injuring nearby normal tissues. With time, the nanoparticles are completely eliminated from the body.
Nanoshells, tiny spheres of glass coated with gold. By making subtle alterations, she found she could tune them to capture specific wavelengths or colors of light and heat up. Dr. West, a bioengineer, suggested tuning the nanoshells to the near-infrared part of the spectrum. Though invisible to the naked eye, near-infrared light can pass harmlessly through skin. Hallis and West reasoned that if they could get the gold nanoshells to accumulate selectively only in tumors and then zap them from the outside of the body with near-infrared laser light, they might be able to burn away the tumors without harming the surrounding tissues.
क्वांटम डॉट्स छोटे सेमीकंडक्टिंग नैनो क्रिस्टल्स होते हैं जो कि कई तरह के एलिमेंट से मिलकर बने हो सकते हैं, जैसे कि सिलिकॉन, कैडमियम सेलेनाइड या कैडमियम सल्फाइड। इनकी साइज 2 से 10 नैनोमीटर तक होती है। 1 नैनोमीटर लगभग 2 सिलिकॉन एटम्स की चौड़ाई के बराबर होता है। ये सेमीकंडक्टिंग मटेरियल्स लाइट को एब्जॉर्ब करने में सक्षम होते हैं। क्वांटम डॉट कौन सा रंग प्रोड्यूस करेगा, ये ज्यादातर उसके साइज और मटेरियल पर निर्भर करता है। इसका कारण है क्वांटम कन्फाइनमेंट। ये इफेक्ट 2 अलग अलग आकार की घंटी के समान होता है। जब बड़ी घंटी को बजाया जाता है तो कम एनर्जी वाली साउंड वेव्स बनती हैं। जबकि छोटी घंटी से ज्यादा एनर्जी वाली साउंड वेव्स बनती हैं। जब लाइट एक क्वांटम डॉट को एक्साइट करती है तो जितने बड़े आकार का वो डॉट होगा उतनी ही कम एनर्जी की वेव्स बनेंगी। इसलिए लाइट लाल रंग के क्लोज होगी। वो जितना छोटा होगा लाइट उतनी ही नीले रंग के क्लोज होगी। क्वांटम डॉट्स वर्तमान में मेडिकल रिसर्च, सोलर पैनल्स, टीवी और सॉलिड स्टेट लाइटिंग में यूज किए जाते हैं।
4. Microencapsulation is a process that makes capsules of solids, liquids and gases on a microscopic scale with the purpose of conserving their properties, controlling the moment and the place they are released. Drugs, for example. Microencapsulation makes it possible to mask the unpleasant smell released by the medicine at the time and place that we determine.
Definition of nanochemistry. It is the combination of chemistry and nanoscience.
What is the nanochemistry? Nanochemistry is a combination of chemistry and nanoscience. Mostly chemistry deals with what? Chemistry deals with matter. And what is matter? Matter is anything which has space and occupies volume. So mostly chemistry deals with matter. And why there is a name is given as nanoscience? Nanoscience, because nano means what? The particle size should be in the range of 1 to 100 nanometer. So here what we are going to do is we are making that matter in the nanoscale range, that is 1 to 100 nanometer. So chemistry and nanoscience. So there is a combination of this, therefore the name is given as nanochemistry.
Definition of nanochemistry. Nanochemistry deals with designing.
So what designing? Designing means planning. The planning of what? To make a nanoparticle size.
And synthesis of materials of nanoscale.
So we are synthesizing that matter into a nanoscale range. So we are planning and we are synthesizing that matter in a nanoscale range.
With different size, shape, structure and composition.
So you can see here the gold has different size and they have a different applications. Here you can see adjusting the nano gold particle size, it has a different application. It can be used in dyes, it can be used in drugs, targeting particular thing. See, there are various application of this gold technology. So by adjusting the shape, size, and you can make use of different applications
and their organization into functional architectures.
by adjusting the size, shape and structure. You can use in different applications. That is, functional architecture means what you are doing, you are arranging that particles and making certain size of that particle, and you are using in that particular application, you are using it.
Nanochemistry is used in chemical.
So you can see here, it is used as a chemical, means for chemical reactions. You know that in chemical reaction we use catalyst, and the catalyst which are used is of very small size, that is in the nano particle range size. And because if the catalyst is made in a nano size particle, it can be used as a catalyst and it can increase the rate of reaction.
Physical.
So by studying the physical properties of that nanoparticle, you will study about how the particle behave in different way, how is the thermal property, what is the melting point, what is the electrical property, because electrical melting, every properties changes when the bulk material is changed into nano size particle.
Material science.
So by adjusting the material, by adjusting in the nanoscale range, you can make a different materials, and you can use this in different application, and you can make different devices.
As well as engineering.
So by using the nanotechnology in nanochemistry, you can make a different vehicles, devices, and machines you can make by using nanotechnology.
Biological.
You can see that in biologically also it can be used. In living organism we can use a nanochemistry by making a drugs, and it can be used in different cancer treatment.
And medical applications.
Nowadays the robots are used to do the operation, and the chances of survival increases.